right, I guess it's time. So let's get let's get going with this. Welcome everybody. My name is Lorenzo Paganati. I'm a drive specialist for Turtle and Hughes, and we're the Rock Automation authorized distributor out of New York City metropolitan area. And in this episode of the Automation Learning Series, we'll cover the migration of legacy variable frequency drives, and especially the 1336 drives, the famous 1336 drives. So if you're familiar with variable frequency drives or of any kind, you most likely have heard, seen, or perhaps configured one of those guys. And they were the most sold drives in North America for a number of years in the late 90s and early 2000s. And there is substantial install base on virtually all types of industries, at least here in North America. So let's dig into this. A quick look into our agenda. So first of all, we're talking about the intent of this presentation really is to better inform you of the importance of modernizing critical legacy equipment, and in this case specifically VFDs. And what are the risks really of keeping this legacy equipment in your plant? Why should you modernize it? So what are the advantages? What are the trade-offs, if any? And we'll touch briefly upon an overview of product portfolio and current features and benefits that you're going to see on the new family, new generation of drives. And then we're going to dig into the migration steps, identifying your drives, if you have a failed drive, what you need to do, or if your drive's still active, what steps can you take, and some extra help section that we might touch upon later. So moving on. So why should I migrate, right? If you have one of those drives installed, the obvious answer really is risk, right? And in this graph here, you see the bathtub curve. It shows you how often a component fails and over the time. And this trend is very accurate actually when it comes to VFDs. So the longer the lifetime of the drive, the higher the maintenance costs and the failure rate. So the drive will be failing more often and it will cost you more money to repair it or replace it. So, and then when an equipment is down and you need to replace a drive, there is this spare scavenger hunt begins, right? So folks go to Google, eBay, oh my God, I need to get a drive here by yesterday. I don't care how much it costs, just send it to me. So you end up using all this time and energy looking for a component that is no longer made and it's not supported anymore. There is a finite number of components out there to perhaps repair it, but then you don't know if the repair shops will be able to do it, if Rockwell will be able to do it. There is also this chance of not being repairable. And then if you do it locally, you send to a shop and they replace a board, the whole drive is not warranted anymore. It's just the board. So chances are that you're going to get a drive that was repaired that's not going to work. So why would you, keep having this risk in your plant? And the other obvious reason is, it's not uncommon for a production facility to be running equipment that's more than 20 years old, right? And most of the people that designed and installed this equipment, they have moved on from the department or from the organization. Oftentimes, these experts, they're being replaced by younger engineers or technicians that they simply can't expect. You can't expect them to hold the same level of knowledge on legacy equipment. It's just not going to happen. And then you have this undertrained workforce that will most likely negatively impact your downtime, your on-time deliveries, maintenance costs. You're going to have more scrap rate probably. And truly, there's no reason to train a workforce on obsoleted equipment. Why would you do that? That's a very short-term investment. You might as well use this time and money to modernize the equipment and get rid of it, get something current. And get something current that can be locally supported. There is plenty of information out there. There is training available, resources that you can use to make sure that your workforce is up to speed with the current technology. And, I get it. People think, oh, but Lorenzo, 1336, I have plenty of them here in my facility. They made this long without any problem. Why should I change? As it does in life, age wins in the end. And serviceability will be very limited, and at some time it's going to be non-existent. So you can end up trapped with an equipment that doesn't have any option of repair or change. And you see here in the graph on a number by ARC in 2018, more than 58% of users don't have any plan to manage their legacy equipment. So they're pretty much in this gray area that they don't know what to do if a problem comes up. So now we talked about the risks of keeping legacy equipment, but now let's look at what the benefits are of modernizing it, right? You obviously want the new drive to meet all your application requirements, right? Make sure that, the motor is spinning, everything is doing okay. But what else do you get from it, right? Connectivity is really the first benefit. When you think of Internet of Things, industrial Internet of Things, newer generation of drives will give you the ability to monitor, control, and assess your equipment remotely. There are very good elements of predictive maintenance that monitor drive components, such as the fans, the life expectancy of digital output relays, motor and machine bearing and lubrifications. And for higher end drives like the 755T drives, you can even monitor the DC bus capacitor, the health of the IGBTs, LCL filters, a number of things that you can look at the drive and have a predictive maintenance aspect. So you know exactly when a component is stressing to a point that you might need replacement. So you can avoid unexpected downtime and taking those predictive actions to enable your component to continue to run and your production to continue to produce, right? And there is also a lot of flexibility. So back in the day in the 1336 drives, you would order a component that was all installed, factory installed. So everything was built to order, and that would just add you on lead time and sometimes in cost. So what happens today is that the 750 series of drives, they're more flexible, that you use a base drive and option cards based on your application. So the investment really is limited to what you need specifically. You don't need to get a full-blown VFD. You get a base drive, and you use the option cards that you actually need for the application, right? And the components are also conformally coded to avoid contamination from substances. You also have the advance of enhanced safety that reduces panel space and achieve safety integrity levels if you need. Have the ability to have a safe torque off system or a safe speed monitoring system. And that's all available on the PowerFlex 750 series of drives, which are the direct replacement really for the 1336 family. And now touching again on the connectivity. So when you think about it, the new generation of drives gives you what we call the premier integration with the Rock Automation controllers. So smart devices, they have grown today. They encompass a lot of the motor and load values in the industry that you want to be able to measure the performance, and you want to be able to configure those guys. And Rockwell Premier integration just gives you, a logical control of the platform, and that's scalable. It's flexible. You can add components, at your own pace, using, for example, application code libraries or automatic device configuration that we're going to talk about next. And so in other words, you have smart devices that give you better ways to configure, better ways to predict, maintain your drives, know about your energy efficiency, and have a modular design. And that, integrates with the control system, so you have better machine productivity, and you can get these drives up to speed faster. You have safety applications done securely and meeting and complying with standards. And one of the advantages that I want to talk about is the automatic device configuration. So let's say, you have a drive that damaged an electrical fault. After you replace it, this drive will receive the network address from the switch. After that, you get downloaded the firmware and the configuration of the drive. So in other words, nobody needs to be in front of the drive, typing on parameters, looking at the list. Perhaps you don't have this documented somehow, and you don't know exactly what the failed drive had. And you're in this, desperado moment. Oh my God, what should I do here? I don't have the equipment. I don't know what to do with this drive. And if you have the ability to use automatic device configuration, if you have a Rockwell controller in your plant, talk to us. We can help you to accomplish this. It's a very effective way to reduce time to repair and provide the ability to get faulty devices replaced very quickly and bring you back to operation. So this is something that can reduce your downtime cost by up to 82%. This is a great feature that Rock Automation drives and the Premier integration is offering to our customers. So now let's dive into the 1336s. So migration action plan. So step one, really, first thing you need to do is to identify your drives, right? There are a bunch of 1336s drives, modules, different types of enclosures, different options that come with it. So really look into your equipment, try to find the sticker with the catalog number, take a picture, and start documenting it. And you will need to know exactly, what type of enclosure you have. Some drives, this one on the right side, for example, is an open type. Sometimes you have a NEMA 1 drive or a NEMA 12. They have different enclosures. Some of them have this keypad on the outside. Some of them don't. So just be mindful. Find a drive you need and start taking pictures and documenting what's on it. So the second step then will be analyzing the mechanical differences, right? So after you found the sticker, you know what drive you have a picture that you can start comparing really mechanically. Okay, I need to swap to a PowerFlex 750 drive. Does the 750 drive fit in my cabinet? Or I'm just hooking up this guy against the wall or something. So it's important to see that 1336 drives, they are typically wider, and they're wider. Sometimes they're taller, sometimes not, but most of the time they're wider. And PowerFlex 750s are thinner, but they're taller. And sometimes they sit a little further from the panel backboard. So make sure you have the right depth available for the installation. Width, again, most of the time won't be a problem, but pay attention to the depth and to the height of how much height you have available in the cabinet. And then again, it really depends of how you're mounting the drive, whether you have an open type device or you have a NEMA 1, NEMA 4, standalone enclosure, for example, then you will choose according to that. So again, to find out what the sticker is, you will look into, you have the picture here on the right-hand side of the drive. You need to remove the cover to access really what the part number is located. And unfortunately, it's not, easily available. You need to remove this cover and take a look into it. Typically, is on top of the drive, a main board. You see the picture here in the middle, and the catalog number 1336, B060, yada yada. And on the bottom, you will see the terminal block for I/O points. So this is in case really you have a failed drive and really you can't really get into the device to get any other information. So the only thing you can do really is open a device, take a picture of the part number, take a picture of the wires that are connected to it right now. If you have any schematics documented, great, have those handy, and make contact with us. Let us know what you need to do and when exactly you need to get this guy replaced, and we can help you. But again, pay attention to the size of the drive, what type of closure you need. And let's say you have an active drive, so the drive hasn't really failed yet. You're not in a rush, but you want to get rid of them. So this will be the step number 3. Locate the terminal blocks and the power terminal block and the control terminal block, especially TB2 and TB3, because those will tell you what type of control schematics you're using, right? If your drive is being controlled by a PLC, or there is some local I/O like a potentiometer on the panel that's sending you an analog command, and then it goes to those types of commands such as 2-wire, 3-wire control. Perhaps you don't know any of that, so you just take a good look at the terminal block that's located on the bottom of the drive, TB1 and TB2. Look into those and take a picture, try to understand what they are. And TB3, which is the control interface option, this is an option that it's not standard. So let's say you want to have 115 volts rated input or output on the drive. Those are not standard, so it's an option board that goes on the drive, And you see here in the previous picture that on the left-hand side, they look like this. They sit right above the control board, the control terminals. So it's an additional control terminal for specific functions such as an encoder or more contact closure interfaces for you. So again, so you have this active drive. What should you do really? Look at this terminal blocks, look at the sticker, have that documented, do your homework, right? First thing to do really is to save the parameters. If you have the ability to drive still running, why not go online with the drive, use Drive Tools software, and you should have one of these 1203 USB converters you can connect to your computer. You access the drive and you will look at some of the parameters that are important for you. I will touch upon them later. And then make sure you have accurate schematics, right? So if your wires are labeled, and if you have schematics on the panel, the paper is disintegrating, it's falling apart, just take a picture of that, make sure you have this document ready for you when you migrate, because that helps you so much. You don't need to figure it out on the fly. Once the new drive comes, you just know exactly what you need to do and what you need to program on the new drive to just, accelerate the migration. And finally, if you have this documentation, if you know what the drive needs to be, the new drive, you can prepare a file, a configuration file that will correlate with the old one, right? So how do we go about that? So here is a couple of the parameters. I created a custom group of parameters that are important, that I judge important when you're migrating it. So you're looking at, for example, acceleration time of your application. How long does it take really to get to the commanded speed frequency that you need? Also deceleration time. What types of frequency command are you using? Is it coming from, for example, like I said, 2-wire or 3-wire control? And also very important, what's your minimum and maximum frequency in your system? If you have any frequency band that you need to avoid that gives you problems, so skip frequency is also important. Current limitation, overload mode, and then becomes the control piece, right? So what exactly I'm feeding my system with from the drive. So if I want to know if the drive is running and I have this relay set up for this on the drive, I need to know what functions those relays are accomplishing, right? So for example, you can have a at speed relay opening at the time that the drive's running, or if your drive is faulted, you want to have the signal. So make sure you have this configuration saved and you know what your new drive will need to have and will need to accomplish to fit the application, right? And then there are other things, obviously, that you want to know, such as the PWM frequency or some of the application specifics, let's say tuning or bandwidth. But those are typically, case by case. There is not really a way to standardize this procedure. But from a component level preparation, so you have the right drive arriving to the facility for your migration, those parameters you see here in this picture really cover most of it. And obviously, very important for your checklist is to have the motor nameplate data, right? So you want to have this available. You want to know what the ampacity of the motor is, what is the RPM, the horsepower number, voltage, etc. And why is that important? Well, 1336 drives, they are, heavy duty per se out of the box. So they can provide you like 180% rated current over more than a minute. And that's just not the case for newer components. So there is a distinction between what's normal duty and heavy duty now. And it's important to you to know what the actual ampacity of the motor is so you can size correctly. Because at times, for example, you have a drive that was already slightly oversized for the application, and then you come with a new drive that's slightly oversized again, so you have this like rough oversized component that you don't need. You're spending too much money on it. You could save a couple of bucks and get done with the application and make sure everything is working. So again, this is the checklist for your active drive, looking at your digital inputs and their functions on your system. being inputs or outputs, your analog types. Let's say you have a potentiometer or you're sending a command from the PLC. Is it analog 4 to 20 milliamps, or is it 0 to 10, or is it something different perhaps? Just look into that, make sure you have that available. Important to know if you have a system that's 2-wire or 3-wire control, you can confirm which one is it. And again, look at those parameters if the drive is still alive. And you can use the software to do it. You can use the drive HMI for it. So you document this, these features here, these parameters, and you know what to do once you get the new drive, or you can prepare ahead of time, actually. So another benefit of using the new family of drives is that, again, you can program it, you can configure the drive before they arrive. So you will create a CCW file. CCW is one of the software configurations we use for VFDs. It's readily available. It's free for download on Rockwell website. And you can use the wizards. You don't need to be aware of, oh, parameter number 150 something means this and that. You don't need to know this by heart. So you can just use the wizard. The wizard will give you a comprehensive way to navigate through these parameters and just plug in the numbers, right? You don't need to know the parameters by heart. So here, motor data, for example, you just put the motor data that you saw on your motor nameplate. So you're just plugging this information here. And motor control, whether I'm using, motor control mode is flux vector, volts per hertz. Maybe you don't even know that yet, but you will see these options available for you, and you can start thinking, oh, okay, this is probably what I need. I will leave this here. And once you get the new drive, you can just download this configuration, and the drive will be ready to go. All you need to do is really hook up and land the cables on it. So that makes things extra easy. There is a lot of extra information on the 1336 series drive to the PowerFlex 750 series migration guide. Documentation name is PFlex AP007. This is the link for it. You can click on it or just Google this title here on Google, and you'll find this document. It really goes deep in the weeds of every 1336 drive module. What is the difference between the 1336 and the 750s, and physically, configuration wise? It's not going to give you like application information as such. Well, if you have a pump or a fan, this is what you need to do. It's more a component by component comparison. But again, it's really good when you want to find information as such. What is my dimension? I want to know the exact dimension of this drive that I have. I can just measure here, but let's say the equivalent 750, what is its exact size? Where are the mounting plate holes, right? So that just gives you better awareness to prepare, and once the new component comes in, you're just ready to migrate it real quick. And then again, just want to briefly touch on this, very important. Look at your terminal blocks. If you have the ability to go into the drive is still active. Use drive tool software or through the HIM. Get a hand on those parameters. Document this somehow. Create a Word document, write on the paper, whatever means necessary. So you document this. So by the time when you're installing a new drive, you're not guessing or you're not testing and putting your equipment to risk again if you don't know what the actual application requirements are, right? And I get it, drive modernization sometimes they can seem to be a little difficult, right? And if you don't want to try to do everything on your own, you can consider our ASP program, and we offer Turing Hughes and the ASP program. We have factory authorized engineers to support the application. And let's say you get a new drive and you're migrating for a 1336, and if you have an ASP engineer to go down and help you with the startup, that includes a 2-year warranty for the component. And the standard warranty is just for 1 year. So if you have this guy coming down and help you out through your migration, you will extend this number to 2 years. So that's one of the benefits. And again, this is locally available. And it's just another resource for you and your team to migrate this equipment, getting rid of those legacy drives. they are just posing a risk to your facility. And that's about it. Thank you guys for watching. Again, if you have any other questions or you have trouble migrating a 1336, you want to know a little more about it, please contact us and we'll be very happy to help. Thank you for watching.